What's up, math scholars and math haters? This is Mr. W. Today we're going to tackle question 4 in the 5th grade math questions that North Carolina released this past school year. The question tells us that Joan went to the bookstore. Go Joan, bookstores are awesome, especially used bookstores. At this bookstore, 3/4 of the books are fiction, and of the fiction books, 1/3 are mystery books. What fraction of the books of the bookstore are mystery fiction books, so which are both fiction and mystery? So in order to do a problem like this and to do it really well, you'll need to know how to translate a word problem and know exactly what you're trying to do here. And what we're going to end up trying to do is multiplying fractions. So let's get started. I'm going to go ahead and read the question, and it asks what fraction of the total books of the bookstore are mystery fiction. So that means they have to be both. And I see that 3/4 are fiction, 1/3 are mystery. And the word that I see most often here is this word of. When we see of in a fraction problem, of is going to tell us to multiply. We can also see that with percents and decimals, but especially in fraction problems, if we see of, that means we're going to multiply. Now, what numbers are here that we can multiply? Well, we can multiply 3/4 and 1/3. So now that we've set this problem up, we've done the hard part. And now I'm going to show us two ways that we can do a multiplying fractions problem. The first way is to multiply and then simplify. And if y'all remember what simplifying is, great. If not, I'm just about to go over it. The other way is to look for common factors using what I call the Bowtie Method. So we'll start with the first way, where we multiply across our numerators and our denominators and then try to simplify our resulting fraction. So 3 times 1 is 3. 4 times 3 is 12. So we now have the fraction 3/12, and I'm looking for a number that can go into both 3 and 12. That number is actually just 3. So I take 3 divided by 3, and I do 12 divided by 3. 3 divided by 3 gets me 1. 12 divided by 3 gets me 4. So my answer is going to be 1/4, which matches answer choice A. Now the other way to do a problem like this, I called it the Bowtie Method because what I'm going to do is I'm going to look for common factors between both of my numerators and both of my denominators before I go ahead and multiply. So I'll start by looking for common factors between 3 and 4. There are no common factors between 3 and 4, unfortunately. Next one, I'll look for common factors between 1 and 4, and there are none. I'll look for common factors between 1 and 3, there's still none. And finally, I'm looking for common factors between 3 and 3, which, that's 3. So I'm going to divide this by 3 to get 1, divide this by 3 to get 1. You see how this looks like a bow tie? That's why I call it the Bowtie Method. And now, I'm just left with 1/4 times 1/3, which if I do my same, let me scoot that up. If I do my same, nope, that's just 1/1. I wrote that wrong. 1/4 times 1/1. If I do my multiplying by numerator, or my numerators and denominators trick, 1 times 1 gives me 1, 4 times 1 gives me 4. Using both methods, I ended up with the same answer of 1/4, and my answer, no matter which method I used, is choice A. But it's always good, like I keep saying, to have multiple methods for solving a problem like this in your head so you can check your work.